Here we're going to talk about resistance and Ohm's law. Resistance is a property that substances have that impedes the free flow of electrons. So objects or substances with high resistance will really prevent the flow of electrons a great deal, whereas something with low resistance allows the electrons or the current to flow very freely. Copper is an example of a substance that has a low resistance. The units for resistance are ohms, named after George Simon Ohm, a German scientist who made an important discovery about electrical resistance, and we'll talk about that in a moment. This is the symbol for the ohm, which is the Greek letter omega. Loads like light bulbs and heating elements have resistance, so they impede the flow of electrons. They make it more difficult for the electrons to move through them, and they convert the energy of the electrons into other forms like heat and light, etc. A resistor is a specific type of load that's placed in a circuit simply to impede the flow of electrons, or in other words, to change the current. If you want to control the current, this is one way that you can do it. There are different types of resistors. Here you can see several different types, and you can see they're different colors, and they've also got colored bands, and we're going to talk about how we use those as well. Let's see how we can determine the resistance of the resistors if we know their colored bands. Here we can see the description of all the colored bands. When we read the colored bands, we start from the end away from the gap. So here's the gap, so we start at the opposite end, so we'll start here. In the first case, we have a 4-band resistor, which means the first 2 bands tell us the first 2 digits of the resistance. The third band, which in this case is orange, tells us the multiplier. And then the fourth one tells us the tolerance. We'll get to that in a second. So here we have the first band is red, which is this one right here, a 2. So that's our first digit. The second digit is a 5 because it's green. So the colored band, the second colored band is green, so we have a 5. And the third colored band is orange, so the multiplier is 1000. So the resistance in this case must be 25 times 1000, or 25 kiloohms. Now the tolerance is plus or minus 5%. That comes from this last colored band, which in this case is gold. So that's this one right here. No, it's not. Let me try that again. I'm in the wrong column. It's this one. So that tells us the uncertainty in the resistance value. So we can add 5% to the 25,000, or we can subtract, and that gives us the range of values that it might be for that resistance. For the next one, we get a total resistance of 460 kiloohms. Let's see why that is. Well, the first colored band is yellow, which is a 4. The next colored band is blue, which is a 6. Now there are 2 more bands and then the tolerance in this case. So the next colored band is black, which is 0. So there's our 460 so far. Then the next colored band is orange. So again, 1000 is the multiplier. So that means we take 460 and multiply by 1000. So we get 460,000 ohms, or 460 kiloohms. In this case, the tolerance is plus or minus 1%. If we look over here, we can see that's a brown colored band for the tolerance. So down here, the brown colored band indicates plus or minus 1%. And the last one has 6 colored bands in total. Here we have the first colored band is a red, and so we'll circle that one. So a 2 is the first digit. The next band is purple, so that gives us a 7. and the third colored band is blue, which gives us a 6. Then we have a multiplier, which is a black band, and a black band indicates that we multiply by 1, and that last, or the second last band, is gold, and so that's going to be plus or minus 5% again. This last band over here is for the temperature coefficient, as we can see, and that tells you how the temperature, or how the resistance will change depending on the temperature of the resistor. If we want to calculate the current that passes through a resistor, we can do that if we know the voltage and the resistance. This comes from a law that was discovered by George Simon Ohms. We call it Ohm's law. It's most commonly written as V equals IR, or voltage across the resistor equals the current through the resistor times the resistance of the resistor. Let's try an example. If a 50 ohm resistor is connected to a 1.5 volt battery, what is the current through the resistor? So our given values are here: resistance 50 ohms, voltage 1.5 volts, and current is our unknown. Using the formula for Ohm's law, we have 1.5 volts divided by 50 ohms, and we get a current of 0.03 amperes, or 30 milliamperes. All right, next we're going to try a computer simulation involving some circuits, and you can do a little bit of reading and some practice questions.